to do those problems down at the bottom, we're going to be doing a lot of similar things that we did above, just backward. So we are now on page 3 in the notes. And we are going to write a polynomial in factored form given the graphs. Now, one big thing that hopefully you remember from all of our inverse stuff in the last unit is that when it says to write an equation, you got to have either y equals or f of x equals. I don't care which label you use, but you need that to show that it is an input-output equation. So either f of x equals or y equals. And we're going to see what we can tell about this equation from the graph. So if you were getting kind of excited going, well, it looks like I can use my calculator to check most of my stuff, you would be right, except your calculator's not going to help you very much here. So this is going to be your real test of whether you understood what we were just doing with those problems. So let's start with the degree. Do we know the degree number for this graph? Nope. But do we know if it's even or odd degree? Yes, we do. Our graph is doing the disco dance. This is going to be an odd degree function with a what sign leading coefficient? Positive. Our right arrow is going up, so we will have a positive leading coefficient. Now, by that positive LC, I want you to write A. A is going to be what we call the leading coefficient. That's going to be our variable name for it, because that will be consistent with what we do with quadratics in the next unit. And A is going to be something that we can't really tell from our graph. Because as we said before, it's not really like a vertical stretch or vertical shrink. It's a number out in front, but it doesn't really do vertical shrink or stretch stuff like it does when it is in that transformed form. So we're going to need to figure out what A is based on our graph, and that's going to be kind of the algebraic solving part on this one. So more on the A value later. Let's see what other things we're definitely sure about. Do we have any x-intercepts? Yep, there's one at x equals -2. And what's it doing there? Bouncing or crossing? Bounce. So it goes up, boink, hits the x-axis, and comes back down. Our other x-intercept is at 4. Is it crossing or bouncing at 4? Crossing. And this is importante because I can write the factors and a good guess at the multiplicities based on that information. So if it's x equals -2, leave some space after your y equals, what would that be as a factor? X plus 2. X equals -2 is the x-intercept or the root. X plus 2 is the factor. Now, if it bounces, what's the multiplicity? 2. It could be 4. It could be 8. We're not going to mess around with that. Go with the smallest possibility, which is 2. So we're not going to worry about those larger even multiplicities. If it's even, just default to a power of 2. So then, see if you can write the factor and the multiplicity for the other x-intercept. So if x equals 4 is the root, x minus 4 is the factor. Since it crosses, we are going to use a multiplicity of 1, an odd multiplicity. So what else do we know about this graph? We see the turning points. There's 2 of them. That's less than the degree. So maybe we've got degree 3, which matches what we have here. What other exact thing do we know? the y-intercept. So our y-intercept is right here at 1, 2, 3. So at 0, -3, we have the y-intercept. Now if you're like, well, okay, yeah, we do have that. But what is that going to tell me about the equation? The y-intercept is what helps me solve for the leading coefficient or our a value. So what I would recommend doing is we are going to write the equation down below. So y equals, we're looking for our leading coefficient. We're going to let be a. And then we'll have x plus 2 squared and x minus 4 to the first. And you don't have to put that implied power of 1, but there it is. So I moved this down here, and the only thing I added was this a value out in front, which is our leading coefficient. It might be 1. It's not going to be -1 because we know our leading coefficient should be positive, but it could be something like 3 or 4 or a fraction. We're not going to know until we solve for it. So how the y-intercept helps us is this is a definite x and y coordinate that works in this equation. So I'm going to plug 0 in for x, and we're going to plug -3 in for the y. So -3 equals a 0 plus 2, then 0 minus 4. So we took our y-intercept, the coordinate, which has an x value and a y value, and we took that x value of 0, plugged it into the equation, took the y value of -3, plugged that into our equation, and now what I can do is solve this equation for a. So we're going to skip a little bit of work here because we've been practicing finding the y-intercept. 0 plus 2 is 2, and what's 2 squared? 4. So a times 4. 0 minus 4 is -4. So what we end up getting is a times 4 times -4, or -16a. Folks, how are we going to separate that 16 from that a? That -16 from that a, actually. This says -16 times a, so we're going to divide by -16 to solve for it. So goodbye. And a equals, are we going to leave that as -3 over -16? What are we going to do with those negatives? Simplify. They change positive, and gross 316 is our a value, which we can now, man, there's a lot of arrows on here. We can now bring that up to our equation as the leading coefficient. Do you realize how amazing that is? We just wrote the equation of one of these crazy graphs without using our calculator. It's awesome. It's so awesome. I feel like I guess, Mrs. Caro. Now, if you're wondering, I don't really like that 3 over 16 value. Did we have to find it? I want to show you what happens if we just had x plus 2 squared and x minus 4. Yep, and let's fix this up. So if I don't put in that a value, does my graph look pretty close? Yeah. It's got an x-intercept at 2 sorry, -2, not 2. So, folks, what I just did here was I hit the trace button, and that allows me to see exactly where I'm at specific x values. So if I type in -2, I see I'm getting a y value of 0. Ta-da, x-intercept. If I type in 4, we see we're getting that other x-intercept. But look at what happens if I type in 0. This says that my y-intercept for this graph is -16. And is that correct? No, it is not. So I have to have this a value here because that is accurately what describes the x-intercepts, the y-intercept, and the relationship graphically. So we do have to solve for the a value because that gets us the exact graph. So I'm going to throw that out in front, and you can see how they're different. So x plus 2 squared and x minus 4. It's got the same x-intercepts. I'm bouncing, I'm crossing, but as you can see, this red line is hitting at that y-intercept exactly. So folks, concept-wise, those are the things that are on the test on Friday. So what we're going to be doing today is more practice with all of this. So let's go ahead and I'm guessing does anybody have any specific questions, or is it like, ooh, it's kind of a lot, but do we have any specific questions, or do we just want to see another one? All right, another it is. So taking it from the top, looking at this graph, what do we know about it? If its end behavior is going down and down, what two things do we know? Even. And what about that leading coefficient? Negative. So the right arrow's going down. So a negative leading coefficient. So folks, that tells me that my a value is going to be negative. I don't need to put a negative in front of that a. The negative should reveal itself when we later solve for it. So just keep in mind that it should be negative when we solve for it. What about x-intercepts? Do we have a few of them? Yeah. How many do we have? 4. This one is at -6, and it's crossing. So x equals -6 will be x plus 6 as a factor. Since it's crossing, we're just going to say multiplicity of 1. Keep it simple. Where's our next x-intercept? 1, 2, 3. X equals -3. This is also crossing. So x plus 3 as a factor with a multiplicity of 1. See if you can identify the next two factors. So I cough like that when I choke on pepper, but after I completely have a coughing fit, I always sneeze 3 times. It's really weird. Is anybody a habitual series of 3 sneezer? So I'll get the bless you, and then shut up after the 3rd one. So folks, here are my other 2 roots at 2 and at 4, and they both cross. So x minus 2, multiplicity of 1, and x minus 4, also with a multiplicity of 1. So folks, what would the degree of that polynomial be if we add up all those multiplicities? 4. Does that seem okay, Coolio, with what we have on our graph? Yep, 4 is even. And there are 3 turning points. So yep, our degree is high enough to cover all those turning points. So it's all good. So what other thing do we know? What's the last exact point? This turkey. 1, 2, 3, 4, 5, 6, 7, 8. 0, negative 8. That's the y-intercept. So now, the y-intercept is an exact point on our graph that's going to help us figure out our a value or our leading coefficient. So I'm going to write that equation below. Y equals the a value. And if you're like, hey, Mrs. Cairo, but that a value is negative, that negative should reveal itself when we solve for it. So it's still just variable a when we are solving for that leading coefficient. So then I'm going to write those factors, x plus 6 and x plus 3. Oh my gosh, and x minus 2 and x minus 4. A lot of them. What are we going to plug in for all of the x's? 0. And then what are we going to plug in for the y value? Negative 8. So 0, 0, 0, 0, plus 6, plus 3, minus 2, minus 4. Now, folks, if I add 0 to all those numbers, what are we going to get? Just all those same numbers. But keep in mind, all of these are joined by multiplication. So that means I'm going to have, let's see, 3, let's do negative times negative is positive 8. Times 3 is 24. And whatever 24 times 6 is, pretty sure that's 144. So, yuck. We get 144a. And how do we solve for a? We divide by 144. Now, am I going to be the happiest person ever if you leave that a value is negative 8 over 144? Can we simplify it? And I don't expect you to know what the GCF is that you can take out of both of these. I expect you to say, calculator, oh, expensive calculator, please help me simplify that fraction. So, folks, we're going to type this fraction in as little negative 8 divided by 144. My calculator goes, what's up? Here's a nasty decimal for you. To turn it back into a fraction, a reduced fraction, here is the key sequence that we use. Let's go ahead and write this up here somewhere where we actually have some room. So to simplify fractions, you type it in and then hit the following buttons. Math, enter, enter. Say it with me. Math, enter, enter. Math, enter, enter. Math, enter, enter. Math, enter, enter. That is going to be our saving grace with these fractions. So let's see what that looks like on our calculator. Let's zoom out here a little bit. So our math button is right below the alpha key. So right below this green one on my calculator, right here, we've got math. It says to fraction for the first one. Hit enter once, hit enter again, and there it is. Negative 1 over 18. So I need to remember that this a value that we solved for, negative 1 over 18, needs to go up here as my leading coefficient. Ooh, I don't like that. That doesn't really look like a negative. It just looks like more of that fraction bar, so we'll put that negative up with the 1. So did we get a negative leading coefficient? Sure did. We met all the specifications of that graph. Questions on that one? All right, folks, let us go into the guided practice, that blue packet.